Okay, Chapter 16, Oxidation and Reduction. Based on the course outline, we do not need to cover the entire chapter, and so we're not going to. We're just going to cover what's in the course outline. So, jumping to 16.2, Oxidation and Reduction. Definitions. So one definition of oxidation is the gaining of oxygen. That's the one that makes the most sense to me. And I think that's where the term oxidation originated. Oxidation is when a substance gains oxygen. So that can be slow or it can be very fast. A slow example is rust. So iron reacts with oxygen to form iron oxides. The iron has gained oxygen. It's been oxidized. Rapid oxidation would include things like combustion. What do you need for a fire? You have to have oxygen. So here we have methane, natural gas, reacting with oxygen. And now the carbon has oxygen. It has gained oxygens. So the carbon has been oxidized. Oxidation is gaining oxygen. So then reduction is the opposite of oxidation. Reduction must be losing oxygen. Redox reactions, though, do not always involve oxygen. So here is a redox reaction where we have oxidation reduction occurring. They have to go together. Here we have lithium reacting with oxygen and forming lithium oxide. So we'd say, well, the lithium is being oxidized. It's gaining oxygen. But what about here, lithium reacting with chlorine to form an ionic compound? The same thing is happening to the lithium atoms, but there's no oxygen involved. So we need a more thorough definition of what oxidation and reduction are. Oxidation is the loss of electrons, reduction is the gain of electrons. And that's often abbreviated as oil rig. Oxidation is loss of electrons, reduction is gain of electrons. So oxidation and reduction have to occur together because if something loses electrons, something else must gain electrons. There's no homeless shelter for electrons where if you're going to lose electrons, you can just put them there. You can't leave them on the side of the road. And if you're going to gain electrons, they have to come from somewhere. Here we have lithium, and over here, lithium is now part of an ionic compound. So it's no longer lithium atoms, this is lithium ions, right? How do you get from a lithium atom to a lithium ion? Has to do with electrons. You lose electron. So if we remove an electron from the lithium atom, it becomes an ion. Lithium has lost an electron. Oxidation is loss of electrons. The same thing is happening here. Lithium atoms are becoming lithium ions. Losing electrons is oxidized. If oxidation and reduction have to occur together, what is being reduced? Is the other thing. Here the oxygen is being reduced, and here the chlorine is being reduced. So here we have O2. So on the reactant, we have O2, and in the product, we have O2 minus. There's two of them. How do you get there? How do you get negative charges? Adding electrons. So we had 4 lithium atoms, and they each lost an electron. And we have oxygen gaining 2 electrons. My brain is, no, it's not 2 electrons. I knew something was off. Each atom gains 2 electrons. Overall, it's 4. There we go, that's better. So the electrons that were lost by lithium were gained by oxygen. And down here, chlorine becoming chloride ions. Cl2. We have to add 2 electrons to that molecule, and then we're going to get 2 chloride ions. So the lithium gained electrons, the lithium lost electrons, chlorine gained electrons. So here we have hydrogen and oxygen reacting to form water. So we can look at this and say, well, the hydrogen's gaining oxygen, it's being oxidized. I'll give you a clue. Oxygen, O2, never gets oxidized. It can't gain itself. O2 always gets reduced. So here the hydrogen is being oxidized. That makes it a reducing agent because it causes the reduction of the other thing. Yes, this is confusing. The oxygen is being reduced. It is causing the oxidation of the hydrogen. So we call this the oxidizing agent. So let's step back from that and think about Hollywood and movies. So you've got a movie star, and how do they get parts? How do they know what parts are up and where to go for auditions? Who helps them out? Their agent, right? Movie stars have movie agents. Do the agents star in the movies? No. They cause the movie star to star in the movies. They cause the actor to be in the movies. So here, the reducing agent doesn't get reduced. It causes the other thing to be reduced. This is like the movie agent, right? He's arranging something to happen for something else. So the oxidizing agent causes the other thing to be oxidized. Oil rig, oxidation is loss of electrons, reduction is gain of electrons. And this is a summary here. Oxidation is loss of electrons, reduction is gain of electrons. The oxidizing agent causes something else to be oxidized, and in that process it's reduced. So the oxidizing agent gets reduced, the reducing agent gets oxidized. I did not make this up. I'm sorry. Okay, identify the substance being oxidized and the substance being reduced in each reaction. So we can look at this in terms of losing or gaining electrons or losing or gaining oxygen. These first two, there's no oxygen in there, and so we need to look at the electrons. So we're going to look at what happens to potassium. Here potassium is an element, it's individual potassium atoms, and over here, what is the potassium? Is it still an atom? No, it's become an ion. It's part of a compound, right? So there's K plus, and there's CO minus in there. So when the K becomes K plus, is that losing electrons or gaining electrons? Losing electrons. Oil, oxidation is loss of electrons. So the substance being oxidized is the potassium. The other thing is the thing that's being reduced. You can also look at it and make sure. Here we're going from chlorine with no charge to chlorine with a negative charge. It got that way by gaining an electron. Reduction is gain of electrons. Let's look at this one. This one's easier. Here's aluminum, and here's aluminum 3+. In this reaction, did it gain or lose electrons? It lost. So, oxidation or reduction? Oxidation. Oxidation is loss of electrons. What's happening to this tin ion? Tin 2+ is going to tin without a charge. It's gaining electrons, so this is being reduced. Now this one, there's no charges, right? What is gaining oxygen? The carbon or the oxygen? It's the carbon. Oxygen can't gain itself. So here, the carbon is being oxidized, it's gaining oxygen. The oxygen is being reduced because it's the other thing. And if you have one, you have to have the other. It's like buying and selling. If you're going to sell something, you can't sell it if nobody buys it, right? And you can't buy something if no one sells it. Let's identify the agents. So we previously identified that this was oxidized. So what kind of an agent is that? The thing that's oxidized is a reducing agent because this is the thing that got reduced. So the potassium is causing the chlorine to get reduced. So the potassium is the reducing agent. Call them RA, reducing agent, and the chlorine is the oxidizing agent. The potassium was oxidized, the other guy is the oxidizing agent. So down here is aluminum being oxidized or reduced? Oxidized. It's going from 0 charge to +3 by losing electrons. This is being oxidized. It's the opposite kind of agent. So that's the reducing agent, and this other guy must be the oxidizing agent. Down here we said that the carbon was oxidized, the oxygen was reduced. The oxygen is the oxidizing agent. I think the reason that some of these terms seem confusing to us now that we have learned more about atoms and ions and things is because of the history and where these terms came from. The terms originated when we knew much less about what was going on. So they called this being oxidized because when they observed this, it always involved oxygen. And then when we learned that that same process could occur without oxygen, we just kept the term. Any questions?